Last week's test. A bonus extra on Maths Dave this week.
Hey.
What is this?
Right, so the first question, use the substitution to find the exact value of this. So we've got the steps that we have to go through with substitution. Start by differentiating, because we need to sort out the dx, so we need to know what dx by d theta is. So dx by d theta would just be a third cos theta. Doesn't go negative, of course, because it's the music system. Shush. Right, and now we also, when we sort out the substitution, we need to sort out the limits as well, don't we? And because we're doing calculus with this stuff, we must put our limits into radians. So if x equals 0, then that means that a third sine theta equals 0. And so a value of theta that would give us that result would be 0. If x equals a sixth, that means a third sine theta equals a 6. Which means that sine theta is a half. And if sine theta is a half, the smallest value of theta that generates that would be pi by 6, sine 30, isn't it? So we're going to do theta is pi by 6. So they're the limits. So we've got that bit sorted out and the limits. We're going to replace dx, so we're going to do this bit here where we write 1/3 cos theta d theta is equal to dx. Now let's see what happens with the substitution. So the integral becomes, instead of 0 and a sixth, it's 0 and pi by 6. We've got 1 over, we're doing 1 minus 9 times x squared. Well, x squared, if you square that, you would get a 9th sine squared theta. So we've got 1 minus 9 lots of a 9th sine squared theta to the 3 over 2. And instead of dx, we're going to write 1/3 cos theta d theta. Okay, so let's see what we can do with sorting that out. We've got a third here. Probably makes sense just to bring that outside the integral so we're not having to worry about that. Now, down here we've got 9 times the 9th, which of course is 1, and it's 1 minus sine squared theta. So that's 1 over 1 minus sine squared is cos squared. So 3 over 2 times cos theta d theta. And of course there's lots that we can do with sine squared theta. You know, we can try and think of it, write it in terms of cos 2 theta or something like that. But we know that up here we've got a cos theta. So we want to try and link up these things and get it to simplify if we can.
Where's your third gone?
The third was this third here from the substitution. So it's a third of. We're nearly there with this all tidied up. Can you see what we've got? If the square root bit there would make that cos theta. So that's actually cos cubed theta on the bottom line there, isn't it? We have cos theta on the top. So cos theta divided by cos cubed theta leaves us with 1 over cos squared theta. And that's why it was such a neat substitution, because our 1 over cos squared theta, we know it better as being sec squared theta, and we know that if we integrate sec squared theta we get tan theta. We're going between 0 and pi by 6, so all that is left for us to do is to sub in those values. That's 1/3 of tan pi by 6, which is root 3 upon 3. Take away tan 0, which is 0, which leaves us with an exact answer of root 3 over 9. That's the way that we should have done that. It is important that we change our limits into radians, because when you're doing calculus with trigonometric functions, you've got to be working in radians. Okay? Some kind of little details about this, and this was from marking them, that you've got to try and really set things out nicely. So make sure that your d theta, that you're consistent about putting in the full integral bit. So if ever you put the integral sign, you have to put the thing that you're integrating with respect to at the end of it, because that had a tendency to get missed off once or twice. Great, so that's that question. Question 2 was, find the exact value of that. Okay? Now, we're coming to expect that if we've got two things multiplied together, it's probably going to be by parts or substitution. If it's substitution, it's probably going to tell us what the substitution is. So this looks like it's two things multiplied together, so it must be a by parts question. Now, one of the things that we know is that, or which way around to write it? It's u dv by dx, isn't it? This is the formula for by parts. It is u times v minus the integral of v du by dx. Okay, so we're thinking of the thing that is going to differentiate, the u bit, and the other thing that we're going to be able to integrate. Now remember, normally we would think, well, x to the 4 gets simpler when we differentiate it, so we'll choose that. Except, we know that we don't really know how to integrate natural log of x. So this time, we're going to set natural log of x as being the thing that we're going to differentiate, because we know all about that. And we're going to set x to the 4 as being the thing that we're going to integrate. Differentiating ln x gives us 1 over x. Integrating x to the 4 gives us x to the 5 over 5. And so we're now ready to put this together. So the integral, which is between 1 and e, wasn't it? The integral becomes u times v, so a fifth of x times ln x, between 1 and e. Take away the integral of v du by dx. So x to the 5 times 1 over x dx between 1 over e. Now I might, if I was just doing this for myself, might have been inclined at that point to write this straight away as being x to the 4 over 5, recognising that it cancels down. And so now we're ready to complete the integration. We've got x to the 5 over 5 times ln x minus x to the 5 over 25, which is adding 1 to the power there and dividing by the new power. And we can put the limits in, and there were a couple of people who did so great to get this far, and then had some slightly odd results when they put the limits in. When we put these in, we've got, watch this, this is e to the 5 over 5 times the natural log of e. The natural log of e is saying, what power do you raise e to get an answer of e? So the natural log of e is just 1. Take away e to the 5 over 25, and I've used my one bracket there, so I don't care about these brackets. Let's do that there, and this would be 1/5 times ln 1, we'll come back to that in a second, minus 1/25. And it did say exact value, didn't it? Find an exact value, so we've got to tidy this up as well. Natural log of 1, that's saying what power of e gives you an answer of 1, and it's 0, isn't it? So that bit disappears completely. We've got e to the 5 over 5, take away e to the 5 over 25, that's 4/25 e to the 5, minus 1/25, so plus 1/25. And that will do as an answer. One or two people had gone even better and written that. So there it all is. And again, that was a past exam question, and it was worth 5 marks. It came fairly early in the exam paper, actually. That's it. And that's maths.